When the James Webb Space Telescope locked its gaze on Betelgeuse, astronomers expected turbulence, but what they got was a front-row seat to cosmic violence in real time. The red supergiant, already infamous for its dramatic dimming in 2019, is now showing unmistakable signs of imminent collapse, massive convective bubbles, towering gas plumes, and shock waves tearing through its outer layers. What makes this moment extraordinary isn't just Betelgeuse's death throes, it's how close they are. At just 642 light-years away, this is the nearest pre-supernova event humanity has ever observed, offering an unfiltered look at what happens right before a massive star explodes. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. The Webb telescope's findings are reshaping what we know about stellar death. From detecting gravitational waves to identifying rare elements like technetium and yttrium, this single observation is unlocking answers about how stars end, how galaxies evolve, and even how life-essential elements are forged. Scientists are now watching the formation of a possible transitional object, something between a neutron star and a black hole, a phenomenon never confirmed until now. For the first time, astrophysicists can match theory to reality with hard, high-resolution data, showing how destruction feeds creation in the universe. It starts with a flicker, a slight dimming in a star that for millennia has been one of the brightest in our sky. Betelgeuse, red giant, aging titan. Then in 2019, something changes. That flicker becomes a dramatic fade. The star loses more than 2/3 of its brightness. Telescopes around the world turn toward Orion, and questions begin to erupt across the global scientific community. Is this it? Is Betelgeuse finally dying? The James Webb Space Telescope has now answered that question, and the answer is staggering. Betelgeuse is dying. Not in centuries, not in decades, but right now, for the first time in history, we are watching a supernova unfold in real time. Webb has captured data and images showing convective bubbles the size of planets rising from the surface. It's recorded hot gas plumes being ejected at thousands of kilometers per second, shock waves rippling through the stellar atmosphere. The outer shell of this red supergiant is collapsing. We are witnessing a massive star tearing itself apart. Not a simulation, not a theory. This is it. This is the final phase of a dying star, and it's happening just 642 light-years away. That distance matters. Because unlike other supernovae we've observed, distant flashes caught long after they've occurred, Betelgeuse is close. Close enough that Webb can study the explosion in unprecedented detail. It's a front-row seat to one of the most violent events in the known universe, and it's rewriting everything we thought we knew about stellar death. We now have live evidence of core collapse mechanisms, long theorized, rarely confirmed. Webb's infrared instruments have captured the signs: gravitational instability, the breakdown of fusion at the core, and massive waves of matter falling back toward the center before erupting outward. The surrounding magnetic fields are in chaos. Plasma arcs like broken circuits around the core, and there's strong indication that the collapse isn't symmetrical, which means this isn't just the end of Betelgeuse. It could be the beginning of something else. Scientists are now speculating that Betelgeuse might not leave behind a typical neutron star, or even a black hole. Instead, it might become something in between. A transitional object, something never directly observed before. If confirmed, this would be a new class of cosmic remnant, a hybrid between extremes. Not quite dense enough to become a full black hole, not stable enough to settle as a neutron star. An unstable, magnetically disturbed core spinning at unimaginable speeds, wrapped in fallback material and surrounded by a cloud of exotic particles. And that's just the core. The outer layers, they're ejecting matter at volumes equivalent to thousands of Earths per second. And inside that stellar ejecta, Webb has identified the formation of elements so rare, they only occur in the most extreme environments in the universe. Technetium, yttrium, elements essential to the chemical evolution of galaxies, elements that go on to form planets, and in the right environments, life. This is where the periodic table gets rewritten. Not in a lab, not in theory, but in the furnace of a dying star. The ratios of these elements tell a deeper story. They trace the journey of matter from the core of a massive star, to the dust clouds that seed solar systems, to the rocky planets that form in their wake. Betelgeuse, in death, is becoming a factory for life. And while the explosion poses no threat to Earth, too distant to do any damage, its effects on the surrounding region of the galaxy are real. Webb's sensors are picking up bursts of electromagnetic radiation, gamma rays and high-energy particles racing outward. These emissions will alter the structure of nearby dust clouds. They will ripple through the interstellar medium, changing magnetic fields, igniting star formation in some areas, and extinguishing it in others. A single star dying, reshaping entire regions of the galaxy. Betelgeuse isn't just collapsing, it's detonating a chain reaction across space. And this matters not just because of what it tells us about one star, but because of what it means for every star. Because for the first time, we have real-time data showing what happens before, during and after a supernova. Before Webb, we were looking at shadows, afterglows, simulations. Now, we're watching the process unfold live. We can trace the convective surges beneath the surface, observe the turbulent magnetic fields breaking down, and detect gravitational signals rippling out from the core. Signals that suggest Betelgeuse may have emitted gravitational waves, an explosive heartbeat of space-time itself. If confirmed, this would be one of the closest and clearest gravitational wave sources ever detected. This is multi-messenger astronomy in action. Photons, particles, waves, all converging on one cosmic event, and it's giving us the blueprint. The data gathered from Betelgeuse could allow scientists to build predictive models that identify the final years, perhaps even the final months of other stars. The ability to forecast a supernova before it happens, that changes the game entirely. It means we could catch the next event live, not by luck, but by design. And it means we're finally starting to understand the true rhythm of the universe's most destructive forces. But destruction in this case isn't the end. Betelgeuse is more than just a casualty of stellar evolution. It's a catalyst. The elements it's releasing now will drift for millions of years through space, gathering into new clouds, fusing into new stars, compacting into new planets. Somewhere, in a system not yet born, those atoms will take shape, and eventually life may emerge again. This is the cycle. A red supergiant dies. A galaxy evolves. Betelgeuse's supernova doesn't just mark an end, it marks a rebirth. Not metaphorically, not poetically, literally. This explosion will feed the galaxy, fueling the chemistry of stars not yet lit, planets not yet formed, and possibly even civilizations not yet imagined. It's the cosmic economy in action. Death creates the conditions for life, and now, thanks to the James Webb Space Telescope, we're seeing that cycle in motion, in real time, for the very first time. No theories, no guesswork, just data. We're watching a red supergiant fall, we're watching gravity win. We're watching matter surrender its form and rejoin the cosmos. And we're learning finally that even stars as ancient and massive as Betelgeuse are not immortal, their lives end. But their death is never wasted. If you found this remarkable, share it. If you want to understand more of what our universe is capable of, subscribe. And if the idea that a single star's death could one day lead to new life gives you something to think about, leave a comment. Because we are now witnesses to a moment in cosmic history that no human civilization has ever seen before, and it won't happen again in our lifetime. The light from Betelgeuse has always been there. Before your ancestors looked up at the night sky. Before language. Before history, for over 10 million years, it's burned in the darkness, a red supergiant. The swollen corpse of a star that spent most of its life fusing hydrogen into helium, then heavier elements as it aged. You've seen it without knowing. In the constellation Orion, the shoulder of the hunter. To the naked eye, it's a warm reddish glow, but behind that glow is a story of pressure, of energy, of collapse. Because stars die hard, and Betelgeuse is one of the largest we've ever observed in this final phase. It's so massive, it would engulf our entire solar system out to Jupiter if placed at the center. But its size is also its weakness. Gravity pulls in, radiation pushes out. For millions of years, those forces balanced, until they didn't. The Webb telescope has given us the proof. The collapse has begun. This isn't theory anymore. Infrared readings show internal temperatures fluctuating wildly. Pressure fronts rising and falling through the outer layers. We're seeing the prelude to detonation. Convective currents the size of continents, shock waves snapping through plasma fields. The shell of the star is starting to fragment. We've never seen anything like it, and it's not just the outer layers. The Webb's sensors have traced activity deep within the core. Helium fusion is no longer stable. Heavier elements like carbon, neon, oxygen. They're being fused under crushing pressure. But that's the final trick. Because once iron forms in the core, fusion stops producing energy. It becomes a dead weight. A mass that cannot be supported, and then gravity wins. The core collapses in seconds. A process that would take centuries for smaller stars now happens almost instantly. That's the wall Betelgeuse is crashing into. This is what Webb has captured, the final convulsions of a star too massive to save itself. Its light has dimmed again. Not by dust or surface cooling, but by the inward collapse of its own structure. Each flare, each ejection, each asymmetric surge in brightness is a death rattle. A cosmic alarm sounding across the void. And yet in this destruction, something miraculous happens. As the star collapses, the outer layers rebound off the core with catastrophic force. This is the supernova event. The flash. The detonation. It hasn't happened yet, but it's close. And when it does, it will be visible in the daylight sky. A second sun, burning for weeks, even months. The energy released in a few moments will outshine entire galaxies. One star brighter than billions. That's what's coming. And we've caught it just in time. The significance can't be overstated. This is the closest supernova event modern science has ever witnessed. Webb's instruments are tuned to every frequency, collecting the gravitational shock waves, the electromagnetic bursts, the particle streams. Every signal matters. Why? Because this is how we reverse engineer creation. The elements pouring out of Betelgeuse will serve as cosmic evidence, like ash from a volcano. They tell us what burned, in what order and under what pressure. And what we're seeing changes everything. We've confirmed that technium and yttrium, two incredibly rare unstable elements, are forming in real time. These elements only exist in the most extreme environments in the universe. They don't form in the cores of average stars. They require a detonation. And now, we know where they come from. Betelgeuse isn't just a dying star, it's a forge, an alchemist in its final breath. These elements are more than exotic curiosities, they're part of the foundation of life-bearing planets, part of the chemistry of you. Trace the iron in your blood, the calcium in your bones, the carbon that forms the backbone of your cells. All of it came from stars like Betelgeuse, stars that lived fast, died young, and exploded with enough force to seed entire galaxies. Webb is giving us the timeline of that cycle in ultra-high resolution. We're not just seeing the death of a star, we're seeing the manufacturing of legacy, and still it gets stranger. The data suggest the explosion might not be symmetrical. This isn't just a spherical blast, it's chaotic, lopsided. Some regions are ejecting matter at higher velocities than others. Jets of plasma are being funneled by distorted magnetic fields. There may be fallback material, portions of the outer shell collapsing back onto the core. What does that mean? It means Betelgeuse's corpse might not form a traditional neutron star, and it might not form a black hole, either. Instead, it could become something new, something that exists in the theoretical space between. A compact object with unpredictable magnetic structure. A rotating remnant shedding mass and light in patterns we don't yet understand. An in-between state. That possibility has been modeled in simulations but never observed. Now we're about to see it for the first time. A transitional object. The missing link in our understanding of stellar remnants, the bridge between collapse and singularity. Betelgeuse might give us more than just data. It might give us an entirely new branch of astrophysics, and the effects of its death aren't limited to a telescope's field of view. The high-energy particles from the eventual explosion will scatter across nearby star systems. They'll disrupt magnetic fields, change the temperature of interstellar gas clouds, even alter the light signatures from other regions of the galaxy. We'll watch in real time how one star reshapes its environment, how a single death echoes through light years of space. And it won't stop there. The radiation will compress some gas clouds, triggering new stars to form. It will disperse others, halting star birth in its tracks. It's not just death, it's redistribution. It's galactic evolution in motion. And this is the lesson. No part of this process is wasted. Not a photon. Not a particle. Not a gram of stellar dust. Even in destruction, the universe builds. Even in collapse there is continuity. Betelgeuse is a lesson in scale, in time, in violence, and in transformation. A star that has outlived empires, religions, civilizations, now ending in front of our eyes, and giving us through its death, a deeper understanding of where we come from, and what comes next. We've always been children of stars, but now we are witnesses, not to mythology, but to physics, to chemistry, to truth. What the Webb telescope has captured is not just an astronomical event, it's a moment of cosmic accountability. Proof that everything dies. Proof that from that death, something greater is always born. It will take years to fully process the data Webb has gathered, but the trajectory is clear. The models are in motion, the collapse is irreversible. And the explosion, whenever it happens, will be the brightest light this generation will ever see. It will not harm us. But it will change us. It will remind us that even the giants fall, that no amount of mass, heat or light can escape the final accounting of gravity. But also that every death in the universe becomes raw material for new creation. Betelgeuse is ending. And from its ashes the next cycle will begin. Soon Betelgeuse will vanish. The star that has burned for millions of years, gone, in a single brilliant act of destruction. But what you'll see, what the Webb telescope sees, is not disappearance, it's transformation. The light will surge, blinding, unmistakable. Even in the daytime sky, it will dominate. Not a twinkle, a beacon. For weeks Betelgeuse will shine like a second sun. Its light will cut through clouds, through city skylines, through atmosphere and memory. It will become a cultural event, a scientific revelation, a celestial reckoning, and then it will fade. Not all at once. Slowly, like the last embers of a fire retreating into ash. Until what remains is not a star, but a scar. A neutron-dense object, or perhaps, something stranger. Something not fully defined. A collapsed heart of what once was. Still spinning. Still radiating. Still rewriting the rules of physics, and will keep watching. The debris field will stretch for light years. A complex network of expanding gases, magnetized filaments, shockwave echoes. A supernova remnant, raw, violent and beautiful. That remnant will evolve, shape-shift over centuries. It'll compress matter here, strip it away there. It'll leave behind traces detectable for generations. Spectral fingerprints of a star's final scream. It's in those remnants that life finds its roots. The dust from Betelgeuse will carry with it the heavy elements, the kind you can't make in labs, the kind you only get when a giant dies. Gold, silver, uranium, technetium. The bones of planets. The spark of biochemistry. In 1,000 million years, in a star system we can't yet see, that material might cool, condense, and become a rocky world. Maybe with water. Maybe with the right temperature. Maybe with life. Because this is how the universe works. Stars die so that others can be born. Death is not the end. It's redistribution. This moment, caught by Webb, is not a final chapter. It's the first page of something else. Something vast. Something inevitable. And now we have the tools to see it all unfold. Because this isn't just a win for astronomy. It's a milestone for humanity. We've always looked up at the stars. We've told stories about them. Built calendars around them. Aligned temples and tombs to them. But for the first time, we're not just dreaming about what's out there. We're measuring it. We're tracking the death of a specific star. Moment by moment. Breaking down the event by temperature, spectrum, Mass, velocity, radiation. We're watching time collapse in on itself. Light from a moment that happened 642 years ago, arriving now, just as the evidence of collapse hits our instruments. This is not stargazing. This is participation in the universe's grandest drama. And Betelgeuse is giving us front row seats. No distortion. No delay. Real-time chaos. But even with all our data, all our precision, all our instrumentation, there's a weight to this moment that's impossible to quantify. Because a star is dying. Not an idea. Not a metaphor. A real object. A giant burning engine of fusion. And the loss is colossal. Betelgeuse is one of the oldest, brightest things we've ever tracked. It's a fixture in the night sky. A constant. A landmark. Soon it will be gone. You will look up at Orion, and something will be missing. That absence won't just be visual. It will be emotional. Because you now know the truth behind that fading light. You'll know the forces at play. The unimaginable heat. The violent collapse. The final blast. You'll know what it meant. What it gave back. What it cost. And maybe that changes the way you see things. Maybe you realize that everything, even the most powerful radiant stars, have limits. Lifespans. Consequences. But more importantly, you'll understand this. Their death matters. Because from that death comes complexity. From that chaos comes order. From that end comes everything else. We owe our existence to events like this. To explosions in deep time. To violent ends we never witnessed, until now. So as you watch the story of Betelgeuse unfold, remember this isn't just science, this is memory. Cosmic memory. Written in light, and for the first time written by us. If that moved you, pass it on. If you want to follow this story through every phase, subscribe. And if Betelgeuse meant something to you, if the idea of a star's death changes the way you see the sky, leave a comment, let's talk. Because we're all watching history, written across the stars.